We are working today on adding and subtracting rational expressions. I'm sorry I'm not here today, but obviously I'm going to do the best I can to still support everybody here. Come on in if you are still having some questions about this, but I'm going to break this worksheet up into pieces and do my best to try to explain how to add and subtract rational expressions. Now, we're obviously going to go back, as always, to things that you know already. Okay, so when you add or subtract fractions, we always need to have a common denominator. So I'm looking at these problems, and I'm going to start off with things you know, and then I'm going to apply it to the algebra. Things you know, apply it to the algebra. Okay, so obviously, if we have common denominators already, then we just simply add the numerators. So this is a very simple problem to start. We're going to add 2 plus 3, so this answer becomes 5/7, and then we are finished with the problem. There we go. Okay, if we have common denominators here, even if it's variables, it could be x and x. It could be x plus 2 if this was also x plus 2. If we have common denominators already, simply add the numerators, or whatever the problem is. If it was subtraction, 5 over x, and we're finished. But at this point, we actually have to talk about something. And that is because x is a variable. It's not a specific denominator like 7. And if we plug in any number for x, remember x is a variable, we can plug in a number right there, like x could be 5 or 6 or -3. All of these answers would still work, meaning if x was 6 right here, and we had 2 over 6 plus 3 over 6, we would add up together to get 5 over 6. Well, that's still the same answer, 5 over 6. But we have to note what is called an excluded value. And this is when we input a number for x, which gives us an error. In other words, we can't actually find a solution. And that's any time that our denominator equals 0, because we can't divide by 0. In other words, 5 divided by 0 gives us an error answer. So this calculation works at all times unless x is 0, and that's what we call an excluded value. So all we have to do is note that, okay, our answer is 5 over x, but we're going to keep this answer unless x is 0. So we're going to put an equal sign and a line through it. So this says 5 over x is our answer, but we're going to exclude when x equals 0. We're going to throw that option out, because if x equals 0 over 0, then we're going to get a no answer. Okay, so just keep that in mind. So go ahead and solve your problems like normal, but when you get to the end, any variable that's on the denominator, you have to incorporate that if that denominator ever equaled 0, it's going to mess up your problem. You're going to get no solution. So we're just going to throw those situations out. All right, back on track. 4 over 5 plus 1 over 2. If we want a common denominator, it looks like our common denominator would be 10. So what we're going to ultimately do, I'm going to show it to you, we're going to multiply this one by 2 to make 10, which means we got to multiply the numerator by 2, and that gives me a total of 8 right there. Over here, we're going to multiply by 5, which means the numerator must multiply by 5, and that gives us a 5 there, and we're going to do whatever the math says, which in this case is add, so 8 plus 5 is 13, and there's our solution. Okay, same idea over here. Since we have two different denominators, remember this x is different than this x because the x here is tied to 2. We talked about that yesterday. Our denominator is going to be the first denominator multiplied with the second denominator, kind of like we did over here. 5 times 2 made 10. So we're just going to list it out. X times x plus 2. And then we're going to go back to the problem, and we're going to incorporate, all right, before this fraction had a denominator of x, which is written right here. That's the x that we already have. What it's missing, however, is the x plus 2. I'm going to do colors here so you can see what's going on. It's missing the x plus 2. So what I need is I need to multiply this denominator, x plus 2, kind of like this 5 has a 2 that I'm not multiplying by. I have to multiply the numerator by the piece that's missing. So I got to multiply this 4 that's already there by the piece of the denominator that's missing. So what I'm going to do is I'm going to think, okay, I started with a 4 here, but to make this a common denominator, it has to have x plus 2 there multiplied. So we're going to multiply it by x plus 2. And we'll finish up the math in just a minute. I'm just showing you the process. We're going to copy the sign, so I'm going to add that with the other equation, the other fraction's numerator. I started with 5, and we're going to compare its denominator. Well, right now, it has the green denominator right here, but it's missing the pink denominator. I need a green and pink on each one of these. So this 5 is missing the pink denominator. So kind of like this 2, I had 2, I needed to get it to 10, so I multiplied by 5, top and bottom over here, right? So multiplied this by 5 and this by 5. I'm going to do the same thing over here. I'm going to multiply it by the pink denominator, which happens to just be x. And now I'm going to simplify my numerator. I don't care if you leave your answer on the denominator in terms of what are these called? Factors. You don't have to multiply it all the way out and put x squared plus 2x. If you'd like to, go ahead. I don't think you need to do that though. But we do need to distribute here and combine like terms. So this becomes 4x plus 8 plus 5 more x, which means we have a total of 9x plus 8 as our solution. And then we got to go back to exclude values. This is where also I like to leave the denominators in factored form, because this means I'm going to keep this answer unless x right here is 0. So I plugged in a 0 right there. I'm going to get 0 times 2. Well, that denominator still makes 0, so I have to throw out 0. Make that a little cleaner. I also have a factor right here. And if x plus 2 is my factor, then when x is negative 2 plus 2 makes 0. And now I have to throw that out also, because that is when the denominator would also be 0. And remember, we can't divide by 0. So this is my solution. These are my excluded values for x. Hopefully this is making sense. Pause this video at any time. All right, let's try the next one. Sometimes you're going to have some denominators where part of it fills in. Like up here, we multiplied 5 times 2 to get 10. But over here, we don't need to multiply 8 times 2 to make 16. That's an unnecessary denominator because 2 goes evenly into 8. So our common denominator here is 8, but all we're going to do is multiply this one by 4. All right, and that's how we're going to end up solving this. To think of it in terms of factors, if you factored 8, you would get 4 and 2, and I'm going to use some colors here. This 4 and this 2 are my factors. Well, this 2 is already part of your factors. That's my green factor. It's missing this pink factor of 4. And that's why I'm ultimately multiplying it by 4. Sometimes doing the colors helps you see what's going to happen over here in just a minute. So this gives us a 2 numerator. I did not have to change that denominator. It already matched. This is a 12 numerator. When I create a denominator that matches, I'm going to subtract that to get negative 10. And then if you want to go ahead and simplify that to negative 5 fourths, that's also fine. Okay. So we're going to do the same idea on this problem, number letter F. All right. So right here, we need to first factor our denominators like we did before. And that's going to give us an x minus 6 and an x plus 3. Now what I'm going to do is I'm going to color these. So this is my x minus 6 factor. This is my x plus 3 factor. So when I make my common denominator, I'm going to compare this denominator with the other denominator. And if you notice, this x minus 6 is already part of that. It's the pink denominator piece. So I'm going to actually say that these two pinks can go together, which means my common denominator is going to be the x minus 6 pink piece and the x plus 3 green piece. And I'll show you that in just a second. Let's see, x minus 6 is my pink denominator, x plus 3 is my green denominator. So what I need is I need each individual fraction to have a pink and a green component. Well, this one already has it, which means I do not need to change this numerator at all. It's already perfectly fine. However, this one over here, I'll do it in a green. This one over here only has the pink denominator. It needs a pink and a green. So what I'm going to do is I'm going to go back over here and I'm going to say, all right, it needs to have this green denominator, which was x plus 3. So I need to multiply 5 by x plus 3. And I'm going to go ahead and do that here as well. So this 3x is perfectly fine. I'm going to write it down. I'm going to subtract this group, which is 5x, and this is plus 15, but this is really sometimes confusing. This minus sign goes with the 5, so it's negative 5 times x plus 3, which gives us negative 5x, and actually not plus 15, but minus 15, which means ultimately we're going to have a fraction. Let's see, we're going to combine like terms. 2x minus 5x is negative 2x minus 15, and there becomes our solution after we simplified it all out. And now we just have to exclude when this factor is 0 and when this factor is 0. So that's at 6 and at negative 3. Okay, I'm going to go ahead and pause this video. Try to work on the other two. I'm going to post another video as well to show the last couple